It's Roger, Mudfossil University. Tremendous news today. I finally closed the case on talking to other universities and researchers on the light experiments. I've contacted Harvard and Max Planck and MIT and Stanford and all of them, and asked if they would critique it, and if they had any challenges to it, then I would address them, and nobody's challenged it. So it's a worldwide acceptance now of mudfossil research in light. And this is red laser, that is accelerated light, which nobody expected. That is plasma. That is ether that surrounds it. That is the Cherenkov. These are the boson charged particle carriers. These are the Higgs fields. This is a new particle that nobody knows about yet that we've discovered. This is the actual particles of light, as far as we can determine. That's what they are. This is the actual particle spinning to the right, drifting to the left. So we are the deepest right now in the research realm of the energy spectrum and particles. Now, what else is going on here? Why do I talk about the magnetosphere? Because I say these particles that I have just shown you are ether. And I have many, many videos about this, so it's not that I have only one. I have very, very deep details and explanations of actually what that particle, which is a dipole, does. It is light that's coming from the sun. All particles of light, heat, electricity, static, every single electronic interaction is one of these dipole particles. Now, what will they do? They will crush against our Earth's atmosphere. And what will happen? The pressure, they call it the solar wind. It's not solar wind. It's magnetic particles that come not necessarily from the sun. They are from space, from every single luminescent body. The pressure of the solar wind on Earth's magnetic field compresses the field on the day side of Earth and stretches the field into a long tail on the night side. Obviously, we are being rubbed through that ether. And that is heating up our magnetosphere. And I say all we need to do is test the temperature of the magnetosphere and to see, is this thing getting hotter or cooler? If it's getting hotter, we're getting more rubbing against, and it's not necessarily just the sun. There's another whole thing as we cascade through the arm of the galaxy. We're being ripped through, and that's why the sun has its perturbations. The sun just doesn't start hiccuping and everything, and that has the same exact situation. The sun is 6,000 degrees at the surface, millions at the corona. We're 70 degrees at the surface, 56,000 degrees at the corona. The only possibility is these are being scrubbed through particles we do not see. That is being scrubbed through particles we do not see. These magnetic particles, which are negatives against everything else is coated with negatives, will create the magnetic anomalies we see on the sun. It's as simple as that, and it's made into a big, big, big thing, and they will not look at the simplicity. All right, as with anything, it's a complete must. Causality, it's a universal principle. Every single thing has to be caused. It does not happen by itself. So all of these things I am going to address, and I have already addressed all of these, but I'm going to make those understood to everyone. Why is the sun's corona millions of degrees and the surface only 6,000 degrees? Why is Venus so hot and no magnetic field? Why does Venus have no moon? Why are we heating up? Why does the sun send out particles that we don't think is anything in space? Well, they're obviously particles, and they are the dark matter and the dark energy. They are electrons. And I have shown this. It's not something that I can't back up with evidence. And nobody else can. And they are the ether, and that's the reason we're heating up. And I say that all we have to do is test the temperature in a magnetosphere, and I can prove this one way or the other. Either I'm wrong or I'm right. There's no two ways. If the magnetosphere is heating up, it means we're rubbing into stronger magnetic concussions. And I'm going to show you this. I have every bit of evidence to support this, and not a single bit of evidence from the other side. So, bada boom. Okay, before I get into this, I just want you to know, you should come up here and look at this. Hydrogen nucleus must be a dipole, standing waves, resonance, and so forth. Ether accepted, and it is accepted now. There's nobody, and they do accept it now. They just don't understand it. So let's start to understand it. All right, let's just start with ether, electrons, and what electron clouds are. All right, I say the whole universe is electron flooded. And what do I mean by that? I mean that everything that is out there in space is literally a liquid of electrons. Some of it's thicker in areas where they're being spewed out more than other areas. So you're going to have dense areas, you're going to have thinner areas, but they are all loaded with light. And that light is the electrons, and light is the ether. And these are the little tiny particles that coat everything. There is nothing in the universe that I can know of that does not have electrons completely coating its surface. Everything you see is painted with electrons. Everything's painted, electrons on everything, because every atom is surrounded by electrons in its orbitals. And every molecule is made up of atoms, so everything has electrons painted on the surface. It's just the way it works. So when you push anything through the air, you are pushing electrons into the other things that are coated with electrons, electrons into electrons. Now, if this pile of electrons is dense and this one is not dense, you have a different interaction than if this is dense and this one's dense. Bang, bang. Now you got a concussion of real magnitude. If this one doesn't have extra electrons, this can push through it easily. And this is what is conductivity and insulation. One lets electrons through, the other doesn't. It's not just a matter of how many extra negative particles are in the material or the medium that you're with. It doesn't matter if it's solid or if it's space, or if it's just, you can look through it and see there's nothing there. Well, there is something there. There's electrons there. And when you're looking through the atmosphere here, close to the Earth, you're looking through material. It's totally material. There's atoms everywhere in there with nucleuses, and the nucleuses are nothing more than little bar magnets. They are not neutrons and protons. They are protons and electrons flooded together until the electrons exceed the positive in that closeness. So they are tagged together with the positives until they become slightly negative. They flood, and then there's a little extra negative comes in, and then nobody else can get in. And I show this with the tractor beam magnets, toys, and it's so obvious once you look at the toys show these things. I'll show you it again because it's so obvious, and once you see that, you fully understand, I hope. Okay, this is Latham's Crazy Machines, incredible tractor beam magnet. Now, watch what he's going to do here. What he's got is a nucleus that he's impregnated with negative electrons around a positive core. Now, he brings this up to it, boom. It will not. Here's what you look at it and you say, whoa, how did that happen? Well, what he has is a nucleus, and he has an electron approaching the nucleus, but the nucleus has become net negative. All right, you always have at least as many neutrons as you have protons, and the neutrons exceed the protons in mass, so they are always net negative. So you always have a net negative when you have, even at the base where you have, let's say, carbon or whatever, where you have the exact same number of protons as you have neutrons. Protons, neutrons, and electrons. They're all the same. Well, no, they're not all the same. You have a batch of electrons in the core with the protons, but the electrons, which they always said were neutrons, the mass, they understand the mass was bigger. They just sort of threw it in as a neutron for, boy, I can never figure out. But anyway, the mass is bigger than the protons, so it automatically becomes negative. All right, it will have a net negativity. The two of them combined together, already you have a little extra negativeness. So you will always have some repulsion from the core. And in the the hydrogen atom, protons are not one big chunk in a hydrogen. It is never going to work because they'd snap together. Hydrogen is a half of a hydrogen proton, they call it. In other words, protons are smaller than they say. Protons are at least half as small as they say, because you have to have a core that becomes net negative, which means half of this is going to be positiveness, and half is going to be negative, and an excessive little bit of negative, and then you're going to have one electron here so close to this that it's going to be hell to pull this away. And that's why hydrogen is so powerfully reactive. Alright, so now here he goes. He's going to be shaking this around. It'll stay with that forever. Now, as you heat things, as more electrons try to flood in, they start shaking. And he's going to do that. That will become heat. At first you snap it like that. It's noise. Now, he's making heat, shaking. Some other ones are trying to force their way in, and they're all pushing each other. And eventually it'll fly out of there as light. Here it comes. Boom. And light electricity, static electricity, discharge to ground, all that is the same stuff. It's all exactly the same. It's just a different way that it occurs. In other words, you walk through the air and you pick up static on you, or you scrub against something, all the electrons collect on you. Then when you go up, you touch a water pipe, snap, it goes to Earth. And it's a crack just like that. It's the same sort of thing as in here. Well, it's not. It's not really the same thing, but it has the same reaction. There's a snap of electricity flying out. Well, how does a piezoelectric snapper send the electricity? I'm going to show you how that works. We're going to go through the whole thing. It's very, very interesting. And it changes everything. And you have to take it you have to step back and look at this. Otherwise, you're going to be walking in circles. I don't care what kind of squiggly lines you put in there, and little lambdas and constants and Planck's this and Michelson's that. I don't care what you do. You're never going to get there until you realize there is no such thing as a neutron. All right, I just showed you about the piezoelectric effect, which is this. You snap, you hear that crack, and what's happening in there is you're distorting a crystal. Now, in the piezo quartz, they are hexagons, and it takes 3 silicon, see silicon atoms? And they have oxygen atoms attached to them. Now, so usually it's silicon dioxide. Quartz is silicon dioxide, Si, silicon, O2, dioxide, 2 oxygens. Well, you look at it and you say, no, that's silicon trioxide. No, it isn't. It's silicon dioxide. There's a silicon. It is attached to 2 oxygens. That's it. This one's attached to 2 oxygens. This one's attached to 2 oxygens. That's the signature. Now, what happens when you stress this and you put it under tension? Because here what's going to happen. Listen. Snap, snap, snap. When I do that, I'm making a spark. I don't know if you can see it here. Where are you? Probably can't pick it up so quick on the... Anyway, what you are doing is crushing this. All right? These spread out. This electron now approaches this silicon. So now you do have silicon trioxide. Now, it says, whoa, get away from me. I do not want you close to me. And as it slides off of the thing in here, and you get down to a certain point, snap. It lets it go and bam, it takes off. Now what happens is it throws it right out. See, watch, boing, that goes away and travels down. And because of electron flooding, another electron will always be available to fill that spot. You will never, ever, 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 10,000 times infinity ever, not have an electron. There will always be an electron available sitting there waiting to be used if it's necessary. That is why electrons exist, to fill these different voids when they show up. And that's how you put an electrode at one spot and it pushes electrons, they just feed through there, they just keep going. When you send electricity into the air, it just spins all over and starts collecting here and there. If it's strong enough in the air, all the way to ground, lightning. Because the other parts can't accept any more electrons. They're filled with electrons. It's strictly like, well, we're going to go into the magnetism, conductivity, you know, their electrons, the about not being any neutrons, the type of shapes are critical. The shapes are absolutely critical. I went around in circles with conductivity and magnetism and how come certain things were much more magnetic than other things, and it ends up being not only the number of neutrons, which is the number of electrons really, because the more neutrons that are in the core, well, not neutrons, they're just big electrons. The more of those that are in the core means the more electrons you will have in the outer orbitals. And then if it's a mismatch, you're going to have additional push away, which gives you a hell of a good magnetic capabilities on both sides. Some of them will be able to suck in electrons and some of them will push them away. Now, let's look at what the shapes consist of, because I think it's all due to cubic and tetragonal. And those two things can twist and bend and send out electrons like crazy, and they're all dipolar angles. So let's take a look at it. Now, I know I ramble on about this stuff, and if you're not interested, that's fine, but, you know, there's a lot to it. I do the best I can, so I'm ramble. So we're into electron flood. Neutrons are electrons. Forget neutrons, they never existed. So everywhere you think there was a neutron, it is the same mass, but it's electrons. And electrons are powerful, and they are powerful in closeness. Protons, the positiveness, seems to be powerful in largeness, but, you know, a weak power, but a huge, huge, huge area. And the electrons are extremely powerful, but in a smaller area. That's my take. They might be just as big. I don't know. I don't have the equipment to test these things. But I do understand the processes that are going on, I believe. And when it comes to magnetism and conductivity, what it is, the only thing that matters is how many electrons you have and what they call neutrons, and the shape. The shape is the killer. I never could pick that up. And then I started looking back and forth, and I said, well, how could titanium not be as conductive as iron and copper and all that stuff? It has a ton of electrons and neutrons. Well, it's not the right shape. You need cube and tetragonal. This is the best. And I think the reason is, what's going on here is these things are being smacked with electricity, and I believe they're twisting or compressing. And when they do, they either compress this way and shoot out electrons, or they're twisting and actually collapsing. So instead of being here, they collapse sideways. And these elongate, well, they don't really elongate, they just twist sideways. Now, because SiO2 is it's a platy polar silicate, they call it. Platy means it's flat. It's flat like a plate. If you looked at it sideways, it's like this. Now, what can you do with that? You can twist it this way. You can twist it this way. You can twist it every single different direction. You can twist these. Now, a cube, you can only twist the same amount in either direction. When you twist it one way, it's going to affect the other direction exactly the same as square. If you have this shape, you've got a difference in the way it emits. It depends on how it's bonded. This is hard to explain, but this will have different intensities depending upon the width and the distance this way. So this will be less intense than when it structurally twists this direction. So what can you do with that? I don't know. There's a lot of stuff you could do with that. And they are doing all kinds of things with these twisty little molecules now. I don't know if they're using silicon. I'm not in the business anymore. I don't do much with this stuff, but I understand how it works. And these, let's say, take copper. Copper has a ton of electrons in a cloud surrounding it. Just as they're everywhere. And if you take copper and you let it, I think it's aluminum. You let aluminum slide through a copper tube, it would just go. We just barely go through it. And why? Well, it's inside of like a cloud of pushing back negatives. It's trying to settle down on them as it falls down through the tubes. If you go look up all kinds of experiments, have all kinds of great experiments. But anyway, let's get away from this. But you got to learn something about the periodic table, and different sections control different things in chemistry. And I like the transition metals in this blue area because they are the ones that life works off of. They don't understand this once again in the medical field. These are the things that transport. These are the UPS guys, the FedEx guys, the guys that take everything around your body, deliver it, and pick it up, and bring it up to the heart and the lungs, and turn it into carbonic acids, and into carbonic gases. And then they also deliver it to your kidneys and your liver and all. They take care of all the chemistry in your body. They feed you, they do everything. And if you don't have these, you're going to be sick. And if you don't have these, it means they're not there because you're either not eating right or you don't have the right bacteria, because the bacteria create enzymes. The enzymes go out and make these or harvest these metals out of whatever comes into you. Now, they do the same thing in waste treatment plants. They use the same chemistry. They go out and they say, hey, bacteria, go out and get rid of some of these heavy metals so we can put that water back in circulation. No charge, man. No way. No problem. They head out. The enzymes are a product of the bacteria. Little bacteria. Now, what do? We take antibiotics. That's antibacteria. I got a lot of videos about this too. So, it's so related. And then the medical people say, we can't understand what's in the body because we can't see the chemistry. I got the chemistry here. The chemistry is right there. It's there. That's the human body. That's a goose's head. That's a goose head body. DNA certified. DNA certified. What can I say? Time to start looking. Okay, so you say, Roger, what is the practical effect of electron flood and what can we learn from it? I say that our atmosphere is heating up because of this phenomena. We are now cascading through dense ether, and it will warm up our planet, not from carbon dioxide, but from scrubbing through that. Magnetosphere will heat up. And this is as simple as it gets. Global warming, yes. Fossil fuel use destroys Earth? Absolutely. Total disaster. Absolute nightmare. The things that are coming out of airplanes and all this fuel is hitting Earth. They call it black goo. Nobody understands that. It's causing all kinds of acidic problems and toxicity in lakes and places like that. It's fracturing and destroying the integrity of the Earth. It's killing a living being, which is Earth. Now, the dense ether, though, will cook us. That will cook us. That's what's going on. And it's easy to test this theory. Very easy. Is the magnetosphere heating up? If it is, we are going through a denser region in space. It's as simple as that. And the reason is because we're scrubbing through more and more particles. And when you scrub electrons into electrons, you create heat. It's nothing more than friction. And a magnetosphere is 58,000 degrees. Now, why would it be 58,000 degrees out there and 70 degrees here? It's scrubbing through the ether. This is a problem that they don't see, that they don't recognize, so they cannot solve. And carbon dioxide is not going to help. I said they have accepted the fact that there is ether. They just are trying to figure a way of making it look like something special. Well, it's nothing special. It's electrons. And they can see this now. This is just brand new, 16th of January. They're finally starting to pay attention, I think. And I think it's a lot to do with Mudfossil University research. We have sent this to everyone. Not a single response. None. Zero. Visualization of rapid electron precipitation via coarse element wave particle interactions. This is through the magnetosphere. They realize now that we're crushing through it. And wow, it's heating us up. And then today, I see this. Plasmapheric Higgs waves generate a reversed energy spectrum of radiation belt electrons. Obviously, it is what they call the pushback or something. Hold on. Observations reveal that electrons in Earth's outer radiation belt possess a spectrum that partially rises with increasing energy, obviously, contrary to common beliefs. Plasma Higgs waves scattered off electrons are found to be the origin of this phenomena. That's because we're crushing through those electrons. Just like, it's just so obvious. So now they have to start to understand these are electrons. They keep talking about exactly what it is, and then they say there's nothing there. It's electromagnetic radiation. I said, well, what is that made of? Well, it's a wave. I said, what is a wave made of? Well, it's a perturbation. I said, what's a perturbation made of? And I keep going, and they finally say, get away from me, get lost. And they get upset. So I'm going to go too. All right? Start talking. Ask people about this. We have the winning hand here, my friends, on every single one of these things. And the same thing happened with the Mudfossil research. Finally, Harvard and Max Planck came out, oh, you love mud DNA. There's no DNA in mud. No, you're crazy. Well, guess what? Now all of a sudden they love mud DNA, but they don't like the fact that it came from giants. That's the problem. All right? Mudfossil University. I'm a problem solver. You might say, Roger, how can you say you're a problem solver? And I say, I went to an interview one day, and the guy said, I need someone who can solve problems. I said, well, you got the right guy. He says, all right. He puts the glass half full of water in front of me. He says, is that glass half full or half empty? I said, I don't know. Let me take a look at it. I drank the glass. I says, it's empty. I'm a problem solver.